Student learning objective: solve applications using systems of linear equations, including at least one of mixture or motion problems. This one is a mixture problem. The admission fee at a carnival is $1.50 for children and $4 for adults. On a certain day, 287 people entered the park, and the admission fees collected totaled $718. How many children and how many adults were admitted that day? So let's start off with some variables. Let's do C equals the number of children and A equals the number of adults. So the fact that 287 people entered the park means C plus A would equal 287. Now each child brought in $1.50 into the grand total. So 1.5 times C would represent how much money was brought in by all of the children. A is the number of adults. If we multiply that by 4, we will find out how much money was brought in by the adults. So if we add these together, that should account for the total amount of fees collected. That is the $718. So we have a system of two equations and two variables. You can solve this with elimination. For example, multiplying the top equation by -4 would allow us to reduce the a's. But in general, I do the mixture problems with substitution because I can quickly solve, in this case for a, out of the first equation. And then my second equation turns into 1.5c plus 4 times this new variable a substituted, 287 minus c. That equals 718. This is now an equation with just c as the variable. We can now solve for c. So we distribute the 4, and we get 1.5c plus 1,148 minus 4c equals 718. When we subtract the 1148 to the right, 718 minus 1148 is negative 430. We have the 1.5c minus 4c, that is negative 2.5c. Now, if we divide by the negative 2.5 on both sides, we get c equals 172. A equals 287 minus c. So if we take 287 and subtract the 172, that gives us 115. So 172, how many children? The units would be children. And how many adults? Here we have a nice story answer to match this story problem.